Alright, so today is the 10th video. Let me show what I did today. The first thing what I did was I didn't watch YouTube today. I just did this exercise, which was which one? This one. It was sentiment analysis. I implemented 3 different models. I used an IMDb dataset, which was basically a binary classification. If a review was negative or positive, and that's it. And yeah, the 3 models I implemented. The first one is the betting net. The second one is with pre-trained weights of Globe, so it's Globe and betting net. And the third one is a recurrent neural network using a GRU layer. And that was it. But regarding this exercise, what else did I do? And for this other exercise, I implemented a little bit of linear programming. And the first thing I did was I'm just solving a cutting stock problem. First through the standard formulation, which is this one, which is basically we have 2 decision variables. I mean, the cutting stock, it's you have an n amount of rows, right, which is like this, and you have to decide how do you want to cut them in order to satisfy some demand of each item. So you have item 1 and item 2, for example, and you have this row, and you have to say item 1 it's of length 17 and item 2 is of length 15. You have to satisfy, I don't know, 5 item 1 and 2 item 2. So this is how you can cut it. For example, the first row, and you have 2 decision variables. The first one is y, the y vector, which tells you if you are using row n or not, and the other variable is x in. It's the number of times I is cut from row n, and that's basically it. So that's it. I solve it with pulp. These are, for example, the solution for a specific use case. For example, if you have 3 items and you have 70 of length and these demands and these item lengths, what would be the value of the optimal value of the rows, which are like these ones. You have to use 2, 3, 4, 5, 6 rows. I mean, there are many different solutions. For example, here we can see that the waist is 23, so we can actually cut another item, but I mean, they are not doing here in pulp. Also, I implemented column generation, which basically it's taking the problem and modeling in a different way as enumerating the patterns. So you think about it as the linear combination of all the different patterns that you can make, and the way you do it is you solve it, a linear optimization problem for a given amount of patterns, and then you try to know which other columns optimize the value of the master problem. And in this way, if your problem is really large, you can effectively do it really quick. And that's it. So it's 2 problems. First, you solve the master problem, get the dual values, and with this you can solve like the pricing problem. And that's basically it. I mean, with this, just putting in the code, I mean, it's very straightforward. The important thing is to understand the formulation. And then there was code for comparing both approaches, and I want to understand how the time varies as you increase the number of parameters. That's it. And I run this, and I mean, it's taking so long, so yeah, but it looks something like this. This one, there was a mistake here, but as you increase the number of parameters, the standard IOP increases very much and the column generation stays somewhat linear. And that's it.